My name is Keshwani. This Keshwani, Keshwani. We are here because we want to prepare for the GRE. We have been solving GRE math problems out of this book here, the official guide to the GRE, the revised journal test. If you do not own this book already, purchase one immediately. You're going to need it. The problem that we are about to solve is the one that you will find on page number 259. Page 259, today is our lesson number 164. Let's take a look at it. They're simply asking you what's the relationship between x, y, and z. Problem number 3. What is the relationship between x, y, and z? And the picture is right here. X, y, and z. That's all. Well, first thing first. This is z degrees. How much is this guy right here? Let's call it w. So w and z make a straight line. W and z make a straight line, which means w plus z must be 180. Let's call it w. So we know that angle w plus angle z is 180 because they are sitting on a straight line, which means angle w must equal 180 minus z. W must equal 180 minus z. Angle w must equal 180 minus z. Let's put it there. 180 minus z. Now we know that the sum of the angles in a triangle equals 180, which means this angle, angle x, y, and 180 minus z must equal 180. Sum of the angles in any triangle, doesn't matter what the shape is, in any triangle equals 180, which means x plus y plus 180 minus z equals 180. Let's see what we can do here. We see 180 on this side. I see 180 on this side. Let's subtract 180 from both sides of the equation. If you were to subtract 180 from both sides of the equation, it will drop out. And what we find is that x plus y minus z equals 0. If you add z to both sides, what we find is that x plus y equals z. Now the z here, the angle z that we're talking about, has a name. This guy that is sitting outside has a name. It is called the external angle. External angle. The corresponding angle, the angle that goes with it, is what I'm calling w. This w is called internal angle. And they are pairs. Each pair, everyone has a pair. If you were to extend this thing, this is y is the internal angle. Right here there is another angle which is the external angle. Same thing here. X is the internal angle, there is the external angle. They come in pairs, internal angle and external angles. The concept that they're testing here is this. What does this say in English language? Z here is our external angle. What did we find? We found that the external angle z equals the sum of these two angles. Somehow we have to articulate it, which is what we're going to do right now. I'm going to put it on the top here. So what we learn is that the sum, the external angle equals to the sum of the opposite to its opposite internal angle to sum of its opposite internal angles in any triangle. In any triangle. It doesn't have to be any particular shape of the triangle. It could be isosceles triangle, it could be an equilateral triangle, it could be an obtuse triangle, it could be an acute triangle, it could be an equilateral triangle. It doesn't matter what sort of triangle it is. In any triangle, the external angle always equals to the sum of the opposite two internal angles, which is what this says. If you were to erase everything from in between here, this concept that we put here just now is this right here, which says the external angle, angle Z, equals to the sum of its opposite internal angles. This is one of the most fundamental properties of a triangle. It appears in the exam all the time. You must know it. So if you didn't know it, there it is, which is why it's in the book here. These exercises that they're covering in this particular book here, until we get to the real exam, all of these exercises they are there for a reason, because they expect you to know these concepts, because they appear on the exam, as I said, all the time on a regular basis. That's it. I am done with my sermon. I will see you tomorrow. Okay? Bye now.